In the lecture about forward application, you learned to look at programs as a chain of transformations applied to an input. There is another way to express such a chain. It is called function composition. The type of forward apply with two functions is this. So if you have a value x and two functions f and g, you can call apply like that. Forward compose, on the other hand, looks like this. It takes two functions and returns a new function representing both functions chained together. So the composition of f and g is a function that, when given an argument, first applies f to it, takes this result, and then applies g to it. You can store this composed function and use it later for whatever you need it. This style is called point-free notation. The name comes from the fact that if you interpret a function in a mathematical way, it is evaluated for a point x from its input domain. In composition we do not provide such a point, so it is point-free, and this is really all but pointless. As an example, say you have an input of some strings representing numbers and you want to calculate the sum of their squares. Here is how the code would look like using forward application. The problem with this is, we transform 2 times in a row. This means 2 runs, or let's say loops, through the sequence including the possible cache misses for large sequences and the resulting performance loss. It would be better to do this all in one loop, a process called loop fusion. With function composition we can achieve this elegantly. Current optimizing compilers are not able to fuse those loops on their own in such a situation because they do not know that our functions are pure and the order of execution will not change the result. So we have to do the fusion using composition. Isn't it nice to think about complex functions simply as the composition of a few simpler functions? In object-oriented programming we have a similar pattern. Complex classes are often composed out of smaller classes. As an example, have a look at this small world class consisting of 2 players. A player again is composed out of 2 even simpler classes. In functional programming, you compose functions the same way, from the lowest implementation details all the way up to the high-level process of your application. As an exercise, express the solution to the previous pass and product challenge with function composition instead of forward application.